Hi everybody. After quite a long time, I'm making another presentation for you all, and it's been very nice to hear most of your comments that you've been posting on the YouTube. So it's good that at least some of these videos are of use, and you can use them in your own ways when you are doing your flying. Today's topic that I wanted us to discuss is a very crucial topic in aviation. We all know about it, and it's called decision making. So, decision making, we don't just decide our actions by using what you call the gut feeling. So, there is a protocol that we follow in order to come to a well-informed decision whenever we are faced with an unusual circumstance. Okay, that's very important. And various companies, training organizations, and the like use different models for pilots to use so that the decision-making process can be followed accordingly. And in the era we are in right now, a CRM is a very, very important tool. We do not just take decisions on our own. We talk, discuss, and consult with all the relevant parties and concerned parties that are involved in the operations of the aircraft. And once we have heard from all of them and their views, then we weigh our options. So it's very important that decisions are not biased, but they are collective, and you have included all your crew members, your technical support team, and the like in order to come to a decision when you are faced with an urgency or an emergency or any abnormality. So the decision-making process that we can use, one of the ways that we can use this phenomenon in, let's say, the fleet that I fly, the Q400. What we normally have on the Q400 is you have the quick reference handbook, okay, which I think is applicable to every aircraft in the world. Every aircraft has some sort of QRH, whether it's a hard copy or whether it's touchscreen, depending on the sophisticated nature of the aircraft. The next thing you have is the MEL, the minimum equipment list, which tells you what you are required to dispatch with should you face a fault. Are you allowed to dispatch with that fault or that faulty component or not? Or maybe you are, and there is a time given for that particular malfunction to be cleared or the component to be repaired or replaced. Okay, you find all this in the MEL very clearly laid out. The next thing you will have is called the airplane flight manual. Okay, and in the airplane flight manual, what you have, there are two sections. There are many sections, by the way, but for the decision-making process that we are talking about here, we normally consult the supplements, okay, which are written documents within the AFM for certain malfunctions and certain flight operations that you are permissible to do, but within limitations. And then after that, you have what you call the compatibility tables. Okay, so what you normally do is that you consult each of these in turn, one after the other. Thereafter, you make your decision whether you are going to continue a flight, or you're going to return to where you departed from, or you're going to continue to your destination, or you're going to ground the aircraft, depending on what the more limiting resource is. Meaning, the one which, let's say for example, the QRH says that okay, it's okay to go. It won't even specify that you can go or not go. Fine, you've done your QRH items. The next thing you want for that particular fault, you want to see if it's in the MEL. If it is not in the MEL, means it's a no-go on the ground. Okay. For example, a hypothetical example I give you is, let's say you don't have the rudder surface, you can't go, and it's not in the MEL. It's not even needed, because it's very obvious that without this you can't fly. The aircraft can't fly. Okay. So you go to the MEL, and the MEL will then give you direction of what is needed. Is it okay? Is it not okay? So, for example, if the MEL says no go, means you won't go. Even the QRH said yes, it was okay, or it didn't specify anything. But if the MEL has clearly indicated in some way that this flight cannot take off, or this aircraft has to turn back, you respect the MEL. Now, let's say the MEL was all clear. Okay, the MEL was all clear. Then you went to the airplane flight manual. Then you go to your supplements. When you go to your supplements, you look at your limitations for that particular fault and malfunctions. Okay, and if you are within the limitations, it's okay. But if you see, oh, this limitation, I am not satisfying it, so you won't go. You see? And then from that supplement, you're now going to go to the compatibility table. Compatibility means that for a particular fault, the aircraft can operate with that fault only when it is compatible with certain other restrictions that you will see coming. I'll give you examples anyway in the following slides. So other restrictions that are present. Okay, so is this fault compatible with what we have, or it isn't? If it's not, you don't go. You see, so you do not just refer to one particular resource like the QRH or the MEL alone or the AFM alone and say I'm good to go. It doesn't work like that, because written manuals like these are a backup to your decision. Okay, if you take a decision based on only one of the resources, or you take your own decision without consulting any of these resources, you will be liable to answering questions from the authorities and your management, and it can even risk your job. All right, so it's very important that you have to have a basis, okay, of proving your decision. Why didn't you go? Why did you divert? Why did you return? And so on and so forth. I hope it's making clear. Okay, so from here now we continue. Let's look at an example of a fault that we can experience, or a malfunction. So before we continue with that fault or malfunction example, I want to draw your attention to the quick reference handbook, the QRH, where there are very important paragraphs in the initial pages that you ought to know and learn and know what they mean. Here's the first one, which says the statement "land immediately at the nearest suitable airport" is defined as land at the nearest airport that offers sufficient landing distance available, and if required, emergency service to support the emergency or abnormality. So here, if there is a fault that you have experienced and in the QRH it says land immediately, you need not refer to any other resources, because the QRH has explicitly said you have to land immediately. You see, that's very important. So remember that some of these statements and paragraphs are very important because they're directing you to do an action. Okay, the other one we have in the QRH is land at the nearest suitable airport, as defined is defined as the airplane may continue destination airport or the nearest airport where maintenance services are available. So in this particular case, on the Q400 FMS, you have a page on the performance page. Then you go to the menu. Then there is an ETP PNR, equi-time point and point of no return on the FMS. And there you enter the airports in the vicinity, including your departure, destination, and maybe another 2 alternates. If I recall, there are 4 fields that you enter. 2 of them definitely will be departure, destination, and the other 2 can be some nearby airports. So you look at the distances from your present position to these particular airports, and then you decide which one is the nearest suitable airport, and you go to that airport. It can be where you departed from, it can be your destination, or it can be some alternate. Okay, and the other statement is about maintenance. So it says the statement "maintenance action required prior to next flight" is defined as follows: Maintenance action refers to procedures which can be conducted by appropriately trained and approved pilots as well as maintenance personnel. That's maintenance action. Next flight is referring to the immediate or imminent takeoff after you have discovered the fault. So let's say, for instance, you have a no starter cutout, and that checklist there is a place which I remember, if you refer to your own QRHs, for those of you who fly the Q400, okay, there is a sentence there which says maintenance action required prior to next flight. Okay, so if you have discovered this fault under this statement, it means it has to be fixed before you can take off. You cannot take off if that fault hasn't been fixed. Okay, it's very important. So the verbatim here is very important. You have to understand what each of these statements mean. Okay, and having said that, what we can now do, let's try and link. Let's give an example of how we can use the QRH, the MEL, the supplement, and the compatibility to come up with a decision on, let's say, a particular malfunction. So I'm just going to give you two examples here in detail. All right, one will be anti-skid system failure, for example, and the other will be we have lost our hydraulic system number 1. So we're just going to talk through, and then of course you all are also seasoned pilots, most of you, and it will be very nice to have your comments as well on how you actually even do this, because aviation is about sharing and caring. So it will be very nice to have your own thoughts as well, which you can also post. So for example, let's say we have an anti-skid malfunction. All right, so with anti-skid malfunction, so if you recall from what I've just said, you refer to all the resources before you say, oh, I cannot go, or oh, I can go, or not, or something like that. Okay, it shouldn't be your gut feeling. Just remember that. Don't use gut feelings. Okay, you must use resources to back up your decision. So with this malfunction, the QRH will say the following. I've just actually taken this extract from the QRH: inboard anti-skid and or outboard anti-skid system, meaning that you can have either one of them or both of them. Okay, so if you read what it says here, it's not indicating anything about whether you can go or not go. Listen very carefully. Here, this part does not say anything whether you can go with this fault or not go. So if you had to just refer to this alone, it means all you are bothered about is your landing distance at the destination. You see? So this is not enough. All right, it's not enough. So after this, you have to refer to the MEL. Now let's see what the MEL says. The MEL says that the anti-skid system, the C is a category, so a repair category. You require one of them. Okay, for example, and it says may be inoperative provided operations are conducted in compliance with the Airplane Flight Manual AFM Supplement 7, which is written for operation with inoperative anti-skid brake control system. Okay, and the rest is just you can read. So this first paragraph is very important that you understand. Okay, so fine. Now we've consulted the MEL, and it actually says it can be inoperative provided you go to the supplement. So what do you do next? Exactly, you now refer to your supplement. What does the supplement say? The supplement says the following. It's a long 2 or 3 pages, so I've just taken out the most important one here. The rest just a bit of reading. If you have it, you'll refer to it for those of you who fly the Q400. So what I'm going to focus on here is the limitation part. If you look at the limitation, look at this part here. Takeoff on wet runways is not permitted. Can you see that? So let's say you only referred to your QRH and you are departing from your departure station where it was rainy. Okay, and you just referred to your QRH and you said, okay, the QRH doesn't tell me whether I can go or not go, but I think it's okay, so I can go. But if you didn't refer to this part, look what does it say. It says you cannot take off on a runway which is wet. So it means that, there we go, you will not depart. Okay, can you see what how you link these things up? I'm hoping that you're understanding. Okay, it's very important. So you inform your crew members or your colleagues that, look, we've looked at the QRH, fine, it didn't specify whether you can take off or not, and the MEL has said this limitation to us that we cannot take off. So let's say we were actually on a wet airport, right? For example, where the runway is wet. Okay, so it means that we cannot depart. Okay, now the next thing we look at. Now I've just here said I've said continue to other parts, so I haven't actually, as I said, copied the whole thing down because it was not relevant. This was the most important part that I wanted to bring to your attention. Okay, the next thing we look at the compatibility. So in the compatibility, the number 7 there is the supplement 7. So it says operation with inoperative anti-skid brake control system. So this is compatible with all other supplements except the supplements that are listed: 3, 8, 12, 13, 25, 26, 35, 37, 39, 45, 54, 77, 110, and 120. So if you have those conditions, it means that it's not compatible. So I've actually put them down sequentially for you. So 3, for example, if you have an inoperative anti-skid system, you cannot depart if you are operating in tailwind between 10 20 knots. You cannot depart with an inoperative nose wheel steering system. It's not compatible. You cannot depart if you think you'll do a steep approach and landing. You cannot depart with takeoff with reduced power, a derated takeoff. Okay, and you cannot depart on unpaved gravel runways. You can your operation from there is a limitation there as well for supplement 26. You cannot operate on those runways, and you cannot operate on runways where slopes are greater than plus or minus 2%. Okay, supplementary performance information for operation on economic runways. You have to refer to this supplement 37 as well. For example, noise management procedures and performance not applicable. You cannot use it with this. ILSC approach, you cannot operate on narrow runways. Obvious reasons: if you have to veer or skid off for any reason and the runway is narrow, you may end up on the side of the runway, which may be dangerous. Okay, and you cannot depart on contaminated runways which have got specific friction values. You cannot depart on runways with slopes greater than 3%, and this is just for a particular airport that has a limiting factor with anti-skid inoperative, for example. Okay, so you can see that we have weighed our options. Okay, very, very important that you understand what is happening. You don't just refer to one particular piece of information and decide. You have to refer to lots of things, including the manpower you have around you. Okay, so and exactly what I've just said is what I've written down, so you can read it. One resource may indicate you can go, like the QRH didn't even say whether you can go or not. Okay, or continue the flight, whilst the other may indicate limitations, like what happened for the supplement in our case in the previous example, which says we can't go if you are operating from a particular on a particular weather scenario. Let's say like a rainy day, you cannot use anti-skid system and take off. Okay, so after you have visited each of these, okay, wherever you find the no-go, it means it takes precedence, it means you stop. Okay, so even though, let's say for example, 3 out of the 4 references indicate it was okay, or it didn't specify whether you can take off or not, but if the last one says you cannot go because there's a certain limitation, you do not take off or you don't go. Okay, and this is your backup. You have a backup to say, if you are being asked why didn't you go, why did you return, why did you divert, you have a backup to answer. Okay, you don't just do things from gut feelings and just from your instinct. Okay, it's very important that you understand this as pilots. All right, I'm going to give you another example here, which is a serious case. It's a hydraulic number 1 failure in flight. Okay, it's a very important one. So again, you are flying and all of a sudden you have a hydraulic number 1 failure. How do you recognize in the Q400 that you have a hydraulic number 1 failure? You'll have the number 1 engine hide pump caution light coming on. You have the number 1 hide isolation valve caution light coming on. You'll have the hide valve closed advisory light coming on the fire protection panel overhead you, and you'll also see that your quantity in number 1 system is 0. These 4 indications will tell you that you have actually lost hydraulic number 1 system. You have to be careful not to just jump into the checklist without knowing which caution light are you looking at. It's so important. That's why in all my videos and all my presentations I've been saying that please do your reading actively. Okay, so once we have this, obviously we call out for a checklist. Once we're at a stable altitude, we've engaged the autopilot, we are calm, relaxed, and then now we can try and go through the problem. So from this example, in this example, what I'm not going to go through the whole checklist. It's not necessary because it's not the topic of this video. The topic of this video is about decision making, whether to continue, divert, or return, okay, or to take off or not to take off. So from the checklist that you guys might have, those of you again who are flying the Q400, there is a part on that particular checklist which says landing distance factor. Okay, so once we have read the whole checklist, we've done our actions, we come to this particular point here, landing distance factor. So how do we apply our decision making here, whether we'll be able to land where we are going or not? So what you do is that you know that, okay, you're going to land, let's say, with flaps 0. For example, let's say the flap failure occurred when we retracted the flaps, you were clean, and then you just had this malfunction. Okay, something happened, maybe there was an airlock in the lines or something happened, or there was a leakage, and you lost your number one hydraulic system. So in this case, you are using flaps 0. So flaps 0, it says on the first row, you'll use what you call a flap 35 chart, and the landing distance factor is 2.65. If using flaps 35, it will be 1.85. These are numbers that you multiply by the runway length at the destination, but there is a way to do it. So how do we do this? You look at your performance graphs. Performance graphs are in the initial page of the QRH as well as in your AOMs and the flight planning manuals. Okay, so what I've done here, the planned landing flap, let's say, is 35. Okay, so first of all, we want to know, with flaps 35, what is my landing distance unfactored? Unfactored meaning in normal situations, in normal conditions, with my weight, my temperature, my pressure altitude, and the runway slope, blah blah blah. What is my unfactored landing distance? So there is a table, there's a chart where there's an unfactored landing distance. Let's look at how it works. So this one here is another copy of it. So what I'm going to do, I'm just going to use the example which is exactly there, so I don't create another example. So for example, let's say your weight is 26,200 kilograms, where the black arrow is. I'm just going to put my own arrow on top of it, that one there. So you draw that arrow vertically upwards, and let's say your pressure altitude for the airport is around, for argument's sake, it's 6,000 feet altitude. Okay, so you stop your arrow there, you hit that pressure altitude line. Then you proceed to the next criteria, which is a headwind, tailwind. So you always stop these arrows at what you call the reference lines. Okay, so here let's say we have a headwind. Okay, the headwind is of 10 knots. Okay, so you go to your 10 knot line and you draw it upwards and you link those two lines like that. From there, now your next criteria is a slope, runway slope. So let's say, for example, here the runway sloping downwards at 0.8%, the way it looks like there. So you're going to go to your reference line, draw a line going backwards to your 0.8%, okay, and then from there you draw a horizontal line taking you right across to the other side of the graph, and that's where you find your unfactored line distance. In this case, it's like 2,800 meters. Okay, so that's how you determine your unfactored landing distance. So with what you had with the normal conditions, you would require, at this weight, at this headwind, at this slope, you require a distance of 2,800 meters minimum, okay, to land. Right, now, because now we have a fault, we have a failure, we now have to refer to something called the unfactored landing distance in abnormal configurations. Now let's look at that. So here we've said unfactored landing distance 2800 feet. Now we look at the unfactored landing distance for abnormal configurations to apply the factor. So let's see how that looks like. So here's that graph again, which is in the QRH. Okay, so here again I'm going to start with these lines, but towards the end I'll modify for not wet but for dry runway. Okay, so again we go to our reference line. We had 2,800 meters unfactored landing distance. Okay, then we go to our factor. Now the factor was 1.85. So 1.85, if it's flap 0, use flap 35, 1.85 is almost 2. we don't have to be exactly exact. We can actually estimate a good estimate which can allow us to do these calculations quickly. Remember, we are flying, the aircraft is in the air, okay, and we are doing all these things, but we have to do as accurate as we can our calculations, at the same time being safe. So we go to 2 and we drop the line like this to a reference line, and now this one here, it's giving you the dry runway and VREF. Okay, so what we do here, I'm going to use dry runway and VREF plus 10. So my speed will be VREF plus 10 for the particular configuration. Okay, so I stop my my line there. I just follow these lines which are on the graph, and then I drop a vertical line downwards. And in this case, I can see that my unfact line distance in abnormal configurations, in the configuration which I have right now, is 6,700 feet. So it means that I need, for this particular fault coming in with no flaps, okay, I need 6,700 feet of runway length. I hope it makes sense. Initially we required less. Now we come in with high speed, all right, quite a shallow approach. We're coming with high speed, so it's quite obvious that the runway length required will be very long. Can you see where we are getting there? Okay, so we have briefed each other on this. Now we compare. Okay, the value we got for the abnormal configuration and factor distance to the distances at the destination and departure, and then we make a decision. Okay, if the value we have, okay, is less than what's available, we are okay to go. But if it is more, so if what we require is more than what the actual runway length is at the destination or departure alternate, we can't land at those airports. It's quite obvious, because you'll overrun the runway. Okay, I don't think I have to even repeat this, it's just very obvious. Okay, let's say if I use simple numbers, you have 10 meters available, for example, okay, but with your fault you require 13 meters. Can you land on that particular strip? No. Okay, sorry, it's not proper figures, but I'm just using simple figures now so you understand. Okay, so what you have to obtain is should be within what you have. Okay, in reality, that's very important. Okay, and then once we've done a decision, say okay, yes we can, no we can't. Now we consult technical team to gather more options. We don't just say okay, let's go, because we can go there, but what if there is no technical assistance at the airfield destination or alternate? Okay, we'll be stuck. Okay, we'll be flying a faulty aircraft. That is another incident. All right, so we have to even seek the advice. We can actually go, but are you happy? Yes or no? They will tell us no, return, okay, continue, there's somebody there. All right, and then you've got to be consulting every responsible person, okay, to come up with a decision. Remember, your co-pilot, your captain, your engineer, your engineering team on the ground, okay, and then you come with a decision. That's after which you now consult with your ATC guys. Okay, remember, weather is very important. You've got to look at the weather. Okay, things can be good on our calculations, but maybe the weather is bad. So will you go? No, you won't. Okay, so that's very important. Okay, and also when you take these decisions, it's very important that you understand that you are working for a company where you are earning your bread and butter. Okay, so as much as possible, you don't want to put them in unnecessary costs. Okay, but having said that, doesn't mean that you compromise safety. No. Okay, you don't compromise safety at all. Okay, but the cost on company, you can, let's say you return back, you couldn't make it because of everything was fine but the weather was bad. Okay, or there was no lights, or there was no lighting. Okay, so you have to return. Now that's not your problem. The company will sadly have to allocate the passengers, reroute them, locate them in hotels, and that's a cost they will incur. But as long as they are safe, all is good. Okay, so you never put cost ever as priority. Okay, that's not your problem. Okay, yes, you try to save, but safety comes first. Okay, and I've been saying this in my presentations from my own training, which I have been given. My instructors who are brilliant, okay, who have been emphasizing this to me and have made me who I am today. All right, so it's very important. Now, very important is also that sometimes when we are starting to do decision making, at any fault, any malfunction, we want to come back. It's not necessary. Okay, I was doing the same thing, but then when I got to know, learn, train, these things, we have to calm down and relax, because the aircraft can still fly. It has fuel, unless it's a very serious problem, like let's say you've lost two engines, okay, or you've something terribly has gone wrong, or there's a passenger who is very ill or sick, we cannot continue. Some exceptional cases are there where I'll not continue, I have to come back. But every failure or malfunction doesn't warrant that you have to have an air turn back. You don't have to. You can continue, solve the problem there, and then decide the next course of action. Okay? So remember that it's not the gut feeling. I keep saying this, gut feeling should be avoided. Okay? So you only turn back when you know that the QRH has told you land immediately. This is very obvious. This is to the point. You have to land immediately. So if you're next to your destination, land there. If you're next to your departure, land there. If you are in between where there's an alternate, land there. Okay? So remember, this is very important. Okay? So finally, immediately means immediately, and that's very important. Okay, now as I close this presentation for now, I just want to say that we all learn as we are doing our job. Learning never stops. We meet various situations, many decisions have to be made. Some are very critical, some are very easy to make, on the ground with passengers. They're very easy to make, but some decisions you always have to weigh your options. Okay, but there is one rule that I have been told and I have used all my time for now as a pilot. Never compromise safety. Safety comes first, not the cost, not the revenue. Okay, never compromise safety. And having said that, I hope this little presentation has just like highlighted the decision-making process when it comes to you facing a couple of issues here and there. But otherwise, we all hope and pray that all your flights are smooth, you have clear skies ahead of you, and you have happy landings. Okay, but please be safe. Till the next time, go well. Thank you.